Now you can see this is our digital elevation model, and if I remove it, this is for too much beginners. Okay, if someone is expert in this, then they do not need to open a new or blank map or something else. Okay, I am doing this because sometimes new users are fresh, which do not have too much experience, or they do not too much used with the ArcGIS. Then they face problems. Okay. Here you can add your digital elevation model, which is mosaic and its name is Watershed. Okay, add it. You can also change its colors. Okay, for example, I want to change its color to this one. Okay, you can see here. This is its a new color. Okay, but if you don't, then okay, it's this one. And for example, okay, this is our original digital elevation model. Now we will need to process it, but before processing, you have to save this as a project. Okay, so click on the save button, and I will save it in a folder which I have created as a name of demo. So I will also name it this project, and I will name it as a demo. Okay, this is ArcMap document and ArcMap project. Okay, save it. Once it's saved, then you can start its processing. Okay, so first of all, what we will do here, you can see the HEC-GeoHMS extension. Okay, something if someone is facing problems, then you something need here. You can see the here customize and extensions. Uh, you must check the spatial analyst tool. Okay, let's wait for it. You can see here this is a spatial analyst tool, and you must have to check this. Okay, let's wait. Okay, now it's checked. Okay, because if you have not checked this, then your processing will not be uh, processed. Okay, so click on the here you can see fill sinks. In the processing tab you can see the fill sinks. Click on this fill sinks. Okay, now they say that what is your input digital elevation model, input them, and here you can see a warning sign. So we will change the our input them. Now input them is watershed. Okay, remember the output the projected them mosaic them is watershed. So I will change it to you here watershed. Okay, and now here you can see the output hydro dam. The output of this processing, this fill sync, will be directed towards automatically to your demo folder. Okay. If they are not directed, then you have to change its direction to your folder. Okay. So click on OK button. It takes little bit time. Okay. If your watershed or digital elevation model is too many or too much data, then it will take much more time. Okay, and also depends on the processor. Now you can see its fill sinks process completed. Okay, now we will move to next process, next step. Okay, I will uncheck this one, and for example here you can see the flow direction. Okay, click on the flow direction. Now here the input hydro dam, this will be the fill. Okay, the one which we have got in as output from the previous one. Okay, the fill. Okay, now its input dam is fill and output will be FDR, and then our FDR will be used as an input in the next step. Okay, so you should care about this, and output location will be the same demo folder. Okay, So FDR completed, the flow direction completed. Okay, if we zoom in it, you can see here the different lines. Okay, so it represents the flow direction. Okay, and you can see here it appears here in this table of content, added in this table of content, and these are different layers. Okay, you can see here these are the different layers. Okay, now go to the flow accumulation. Now you can see here its input flow grid is FDR. So it uses FDR as an input and it will give output flow accumulation by name as FAC, flow accumulation. Okay, click on OK. It takes too much time when your data is more than one digital elevation model, okay, or two digital elevation model, or you have many more digital elevation, because for sometimes the watershed area is more or large and you have downloaded many tiles of the dam, for example 30, 40, even 100, 200 digital elevation models. In this case we have only two, and we have mosaic the only two digital elevation model, but sometimes for your watershed, for your study area, you may have 100, 200, or even 300 or less, for example 50 watershed, 50 digital elevation models, and then it will need much more time. Okay, so flow accumulation will complete. The flow accumulation process completed. Okay, and if we uncheck this FDR etc., and we zoom in to this, so you can see here the different flow accumulation paths. Okay, you can see. Okay, zoom out to the full extent and you can see this is the flow accumulation output. Okay, now we will proceed to the next step, which is stream definition. Okay, this step is too much important. You can see here input by default it takes as a flow accumulation. Okay, and you can see here the number of cells to define stream. Here by default it is 87,058, and you can see air square kilometer to define a stream is 73. So if you increase this area, you will also have, for example I increase this to 200 square kilometer area. Okay, then we will also, you can see the number of contributing cells to this area also changes. Okay, and you will, for example if you are increasing the area, you will get minimum sub watershed. If you are decreasing the area, you will get many sub watersheds. Okay, I will see you show you this later on. Okay, so click on OK. Okay, stream definition completed. Now we will go to stream segmentation, and by default it takes input stream grid as the stream definition and flow direction grid as FDR, but I have to uh, first of all check this FDR. Okay, stream segmentation. Okay, FDR and stream, and it will give output as ST